Hello, everybody, and good morning. This is Jonathan Nicholson with ISP Supplies. Today we have Philip Rushton on the line with us from CableAML. He's on the line with us for a part 2 of the Racom Ray3 24 gig connectorized radio solution webinar. He has put together a detailed breakdown of the product niche features and performance factors and how the product matches up with the competition. So, Philip, welcome, and the floor is yours.
Thank you very much, Jonathan. Well, welcome, everyone. Okay, I just want to spend a little bit of time talking about the Racom Ray3 and really how it sits within the marketplace relative to the competition in that band. So, let's first of all think about the market sectors for the Ray3. There's a lot of very good backhaul products available. But I think the thing to kind of realize about these products is that really each one is aimed at a specific sector of the market. Not all applications are the same. So in that sense, what you need to be able to do is to make certain that really understand the main features of the Ray3 so that it can be fitted very well into the applications where it's got a very clear advantage over the competitors. On this slide, the last little bullet point is actually taken directly from the Racom website, and this is really their kind of underlying philosophy of the Ray3. So Racom really described the Ray3 as a high-speed point-to-point microwave link, suitable for links in the most challenging conditions. Is designed for high-performance links with maximum reliability, exceptional system gain, and resistance to disturbances. So that's really the main thing. The exceptional system gain is the point that I would stress, and that really allows us to give maximum reliability and resistance to any interference or disturbances that we have. So looking a little bit more specifically at the areas for the Ray3, it does operate for a 24 gig product really over a very long range. You can get ranges up to 20 miles out of this. It's really focused where there is some extreme weather conditions. Certain areas of the US get a lot of rain, tropical rain. So that's something that needs to be considered at 24 gig. The Ray3 is very well adapted to that. The availability is important. You can get 5 nines availability out of this system, and that's important if you're deploying a network that you're providing services to customers over. They're not interested in the technology. They just want to know that it works all the time. So from a design perspective, the availability's got to be good and solid. A lot of 24 gig products are around. One of the key little features of this is that when systems are deployed on a tower, you can have multiple systems on a tower. You can even have the antennas actually touching. And that's a fairly unique feature, which just makes physical deployments really a lot easier for the system. So where you've got those sorts of 4 conditions, this is really where the Ray3 really excels in the marketplace. Now let's look at a little bit more specifically at the sort of competitive products that might be around. And I like to consider the competition really in a couple of areas. First is actually looking at products that also operate in the 24 gig license-free band. And then the other is really looking at other microwave point-to-point products operating in a number of other bands, all of which would be license-free. So let's start off looking at some of the products in 24 gig band, and I've done a little list here of products that I could find that had FCC approval. There may be the odd other one, but this is a list of products. These are all good and mature, solid products. But as I said before, everyone kind of focuses on a little bit of a different area of the marketplace. But that's just there for reference. As I said, a good range of products. So when we look at the Ray3, we want to consider the competition to it. And someone is considering what product should they buy. I would point to 3 things. that you need to really focus on with the RAy3, and put those next to whatever the other product is that you are comparing. And I would encourage anyone to go and talk to the sales team for those respective products and make certain that you've got the absolute facts clear. But the first and most important thing is the available link budget. The RAy3 does have an EIRP 56 dBm, does transmit a +10 dBm, and you can have antennas anywhere between 1 foot and 4 foot. So all of this really does correspond to a very good available link budget. And really with any microwave link, that's probably the most important thing, because having an adequate link budget, particularly at 24 gigs, is what really determines how reliable the link is going to be. And that's probably the most important feature. So I would encourage anyone to get the data from any of the other competitive products, put it next to the RAy3, and then you can make your choice. The next really important thing is about flexibility. It's worth saying that within the 24 gig band, we've got in the States, we've got 200 megahertz of spectrum, but there are bits of the spectrum where there is interference. And if you've got a radio system that requires the whole 200 megahertz to make use of, to use all of that, then you can get problems. One of the great advantages with the RAy3 is that you've got flexibility. So you don't have to use a fixed channel bandwidth. You've got channel bandwidths going anywhere from 3.5 to 112 megahertz. And you can put those channels anywhere you like within the 200 megahertz of spectrum. So there's no physical duplexer, no restrictions in that way. So if you do have interference, then you can work around it. And that's a really important feature. Again, for making certain that you've got a reliable and solid link for your customers to use. The other key thing to note is that it is a full FDD architecture and does have a very low latency. That's very, very important. Not all of the competitive products have latencies as low as this. And certainly with any network where you have backhaul, a number of backhaul links potentially for customers, latency is really something that needs to be kept under control, as it does have a detrimental impact on the user experience for end users. So those are three really important features that I would suggest that anybody looking at the RAy3, comparing with any competitive products, look at those three, see what those other competitive products do, and then you can balance and make a logical choice. Customers always kind of say to us that the price is too high, and in fact, to be honest, if a customer didn't say that, then it's about always negotiating a good deal. So we understand that, and that's a fair comment. But there are some things that I think that really need to be highlighted here. The cost of the radio is obviously an important thing. But also has got to be looked at what the total cost of the installation is of actually putting the whole product up, getting everything in place. And a lot of you guys that deploy networks know and understand those installation costs very well. I think all of that lot needs to be put very much in context with the value of the revenue that's running through the system. And that, I think, is something that certainly for larger links is something to really focus on. And at the end of it, it's the cost of dealing with any network failures. If there's not sufficient link margin, if you haven't got your link availability where it is, if the link goes down because some poor weather goes through, or there's some interference or something like that happens, there's a real cost in the network of dealing with that. So having a product that's got all of those flexibilities in, all of the price of everything needs to be looked at in context with all of those important features. It's about having a reliable link. Let's consider some of the other bands now, the other license-free bands. and I've listed out 4 of them here. So we'll walk through a few of these and see really what what the competition looks like. And it's worth saying really here that you know, you don't actually really need to look too much detail at the individual products. The frequency band itself is the thing that really determines what you can actually do with the with any link. So let's start off looking at the 5 gig link. I mean, this is a great bit of spectrum. The FCC is really gives us quite a good amount of power to use in that space. Radios can be really very cost effective in those bands because of the easy availability of chipsets. But the downside with this really is that relative to some of the higher frequencies, the antenna beams tend to be somewhat wider. So there's plenty of scope there for interference. There's also quite a few point to multi-point systems that operate in that space. So when you've got a lot of interference like this, again, it becomes difficult to guarantee a service. And at the end of the day, it's about being certain that a link works so that you can provide a solid and reliable service to your customers. Let's look at frequencies above, now above 24 gigs. Certainly in the upper bands between 57 and 86, there's a lot of interest there because there's significant amounts of bandwidth that can be made use of. So some of the, the kind of the headline throughput numbers do look very, very attractive indeed. And there's a lot of emphasis being put on developing products in that space. It's a good and exciting area. But at the end of the day, really, physics dictates a lot of what goes on. Transmission in those bands will always have more attenuation than it will at 24 gigs. You can't really escape from that. A lot of this extra attenuation just comes from things like atmospheric absorption and also rain attenuation. They're the main 2. So let's have a little look at atmospheric absorption. I've got here a little plot that shows the attenuation at different frequencies of the system, and you can see it's done also at 2 atmospheric pressures, one very much at sea level and one at around about 10,000 meters. So you can see the difference. But 24 gigs, you've got something like 0.2 dBs per kilometer of attenuation. Between the 57 to 86 gig range, it really does depend exactly where you are. There is quite a lot of attenuation that happens around about the 60 gig band, the lower bit of the 60 gig band, where there's some oxygen absorption. As you move up in frequency a bit, it really does get somewhat better. But you can see, either way, you do have more attenuation than you would at 24. But there it is. So that is a little issue. Let's look at rain attenuation. And this is really something that's, again, is difficult to avoid. So here, I've shown the numbers for 25 millimeters, or basically 1 inch per hour of rain. And you can see roughly what you get at 24 gigs, 3.5 dBs per kilometer. At the higher frequencies, it's really significantly more, somewhere between about 9 to 12 dBs per kilometer of attenuation. So rain is a real hindrance, particularly at the upper bands. So if systems operate over a relatively short range, it's probably not too much of a problem. But if the range is anything much over a mile, then those systems are really just going to struggle if there's any kind of weather going through. So really, sort of looking at the physics of this, these upper bands with the rain attenuation and the atmospheric absorption make it very difficult to get reliable links over long ranges. There's also just another kind of practical thing really, and that is that really to give these systems a good system gain, the antennas themselves have a fairly narrow beam, and it can be, if you're trying to get something running much over a mile, you're going to be dealing with about half a degree, something like that, of beam width on the antenna. So alignment is difficult, and obviously alignment might go off a little bit over time as well. So that, again, it's a practical thing, but it's rather difficult. So, these bands, they are really good and solid solutions, and there's some excellent products available in that space. But really, if you've got any kind of range, then they're going to begin to struggle, and you're better off looking at something there within the 24 gig range, 24 gig band. But at short ranges, yeah, they provide good solutions. What I want to show you here is just a graph that shows downtime, or this is basically availability for a system. And what I've got here is I've put two systems together. So I'm actually basing this near where ISP Supplies are based in Austin, Texas, and I've set up a 2.5 mile link. And I've got a RAy3 running, and then also kind of next to that, there's a typical 70-80 gig product as well. And both of these sets of numbers are taken off the manufacturer's simulation tools. So the data from the Ray is taken off the simulation tool that's on the Racom website, and then the 70-80 gig is similarly from the other manufacturer. But what I just really want to point out is what I'm showing here in terms of downtime. And if you want to have a system that you're running, and I've set it up here with 1 gigabit per second, and you want to say, okay, within my system's design, I really want to be certain that I've got at least 900 megabits per second, and I want to have it less than 5 hours per year of downtime. That's an availability greater than 99.94%. None of the 70-80 gig products would achieve that. You can achieve that with the RAy3 just using a 2-foot antenna. So that's a kind of dramatic example, really, of what I mean by the availability. It does correspond very much to a downtime. In which case, under those conditions, ultimately your customers would be raising complaints and having problems. So you want to keep that downtime as low as possible. So that are my thoughts on the competition around the RAy3. Really, it's about focusing on the link budget and the availability. These are the most important features, so that you can have a reliable link, and then you can provide a good, solid service to your end customers. Thank you very much.
Excellent. Thank you so very much, Philip, for putting together all those examples and information as well. I'm sure a lot of questions will arise. So if anyone has any questions, please email them either to Philip directly at sales@cableaml.com, or just send it to sales@ispsupplies.com. We'll be more than happy to get you all the answers and see if this will be a perfect solution for your application. Thank you, everyone that is joining us. And if anyone has any questions, once again, it's sales@ispsupplies.com, and please follow us on YouTube as well, youtube.com/ISP as well as on Facebook, facebook.com/ISP Supplies. Thank you very much, and have a great rest of your day.